All right. So, hey there, welcome again to the obbg development stream. Last time, for the last several episodes, I put in background loading. Why has this not gotten updated? Why is this out of date? Oh, because I re-recorded a stream to replace the missing stream that didn't get archived. How do I bring this up to date? Git checkout. I know there's a right way, but user E8. I don't know. I think my head might still be detached. This is stupid Git stuff that I don't know. Git. I don't know. What do you reattach head? I don't. I mean, why is this like? Come on. There's one command somewhere. I haven't made any changes, so I don't care. Is that? Am I still detached or not? I don't know. Stupid Git. I'll leave this up for Caleb. Check out old version. I think I'll make this one. Commit them. Yeah, what? By performing another checkout. Okay, so maybe returning to latest version. Okay, so that should have done it. Okay. So obviously it brought this up to date, but okay, so previous stream on today's stream. So all right. So I don't know what I'm going to do. I just kind of felt like I should work on it a little. I had meant to over the weekend, or I kind of wanted to over the weekend, but I never got around to it. So, so the pending task is that now that I've got the background loading of the, I was going to explain what we did recently, yeah. But now that I've got the background loading of the meshes and the procedural generation working, is to fix up the statistics for those things and to be able to look and see what is going on with them and make sure everything's working right. I mean, because it seems to be working and it's faster, it's definitely in the background, but we don't know for sure. And I still have the mesh leaking problem that I'm generating too much mesh data. I don't have a way to cap how much mesh data gets generated. But that mesh data thing, I think, is going to be a tricky, hard problem, much like the background generation was a tricky, hard problem. And so I don't want to get into it right now. I want to give myself a breather from doing that. So doing the statistics would probably still be nice, but I think we can live without it. What I want to do instead is, let's see, let's set the view distance to something known. View dist. Okay, let's just set it to 800, let's say, and see if I can see when it stops rendering. I have to rebuild all. I didn't see what that error message was. Why is that in a square? Oh, it's not in a square. It looks like it's a square. I think it's a circle if I go up high enough. Yep. All right, so that built pretty fast. Be able to see this in the stats. Q chunks, you can see that increasing. We can count how long that takes to hit that 441. And then let's try that. 1001, 1002, 1003, 1004, okay, so 4.3, something like that. It doesn't matter if those aren't seconds as long as I'm consistent. So now let's find num worker threads. Num workers. Am I in the wrong file? No. What do I call that? Num mesh workers, of course. Oh, look, I've forced it to 2. Let's force it to 4. 1001, 1002, 1003. Wow, okay, so that's a bit faster. Let's push it up to 6. 1001, 1002. That's even faster, except that it crashed when it got to the end. So let's go to a debug build and see if we can reproduce that. So do a rebuild. And that one, of course, didn't crash. It crashes in release, did not crash in debug. Give it a couple tries since it's a thread interaction thing. All right, let's switch back to release and see if it's reproducible. Nope, it doesn't reproduce. That's annoying. All right. Well, let me turn on debug info so we get some kind of info. I guess line numbers only. And then the link, generate debug info. So just in case it does happen again, hopefully we'll get better data. And then let's push the num mesh workers up to 8 and see if that is faster. 1001, okay. Add ref count. It's inside of mutex. All right, so let's, if GC equals null, add them in 3. That's weirdly non-smooth. And now it's not repeating, not crashing again. All right, so let's try counting. I think I've been counting inconsistently, whether I count from the first blue frame or from when it first starts running. 1001, 1002, so 2.2 seconds. Let's go up to, I think I have 8 hyperthreads, so this should start slowing down. It should, or be inefficient. 1001, 1002, yeah, it's very spiky. It seemed like it was faster, but that may be limits of my counting efficiently. 1001, 1002, 1000. Whoa. Okay, so the problem is now we're stealing from the render thread, so it managed to actually generate them a lot faster, but the render thread wasn't getting called. So, so all this crazy math up here ends up basically the core thing is that the main idea is that if you had a lot of hyperthreads but not cores, which rather than actually counting how many of each of those things I have, I just use half of the number of procs. But maybe seems like the hyperthreads maybe help. So let's do something like that. All right, so let's live with that. We'll see if that bug ever triggers again while I'm running. Okay, so that took a little while. 1001, 1002. So yeah, 2 seconds to build everything out to that radius. So now if I set the radius back, so the whole point of this is I'm not doing stats, but I just wanted to get some feel for how this stuff works. So let's set our view radius to 1500 and see, watch it draw in the distance so you can still see it's drawing in. All right. Now, yeah, I mean, I have timers here. You can see the frame rate stuff at the top left. So I could easily add something. If I knew when it was done, I could easily add timers. But I wasn't expecting to actually spend as long as I did spend looking at that. I expected to just get a quick number. What is that texture? That looks really weird. Am I stretching it wrong, or is that actually what it looks like? Oh, it's a wood texture. I see. And rotated the wrong way. So I either need to rotate that in my code or need to rotate the textures. So I've already forgotten what I was saying. Derp. Oh yeah. So I could easily count it, but it's wouldn't be trivial, I guess, when the render queue is 0. Yeah, it wasn't immediately obvious to me how I would know when it was over, whereas watching this number go to 441 was pretty easy. So yeah. So we're looking at this the other day. We can see if I can outrun the procedural gen. And mind you, this is, I'm flying very fast over this. Like, if these are Minecraft size things, your Minecraft walking speed is way slower. Oh, did we hit this? We hit this. We didn't hit this line. So the problem is not that it's null. The problem is that GC is stale. And if it managed to, let's go to disassembly. And view or register windows. I don't remember this now. Oh yeah, registers. Is that a valid pointer? It seems likely that we have an invalid pointer here. Is it possible that, do we need to add ref count before adding it to the queue? We might need to. Wait, why do we add ref count and release it here? Generate chunk, add one. No, this sets it to 0 because it's not, nobody else can see it, so there's nobody who could free it on the other threads yet at this point. Nobody has access to it except this guy. Then we add it to queue, at which point somebody else might have it. And we don't touch the ref count there. So it's our job to add to the ref count. So first of all, this is a bug. I don't need to release it here because nobody's added it. So we just want to do this. And second, what I want to actually do is add it first. And then I do want to release it there. So, okay. So I don't think that would be this bug, but I think that code was wrong. This could also be, well, GC would be null if it were malloc failure, and it would fail sooner. Yeah, I don't know for sure. Which algorithm are you using for hidden face removal? Well, Z buffering, backface culling, that's all GPU things use. And then in terms of hidden faces in the terrain, it's just, it only draws the faces at boundaries between solid and empty space. So it doesn't create any faces under the terrain. But if you had caves in here, it would always draw the caves all the time and rely on the Z buffer to do hidden surface elimination. Anyway, Joe, yeah, I was going to say, if you were Minecraft, you'd be walking along, I don't know how fast Minecraft walking speed is, like this, maybe? So, of course, you hardly ever even see that horizon in this terrain. But even if you could see the horizon, you would never be able to outrun it, I think, in the current stuff. However, we're not doing very much procedural generation because our terrain is just a height field. So another thing we could do is make it more complicated, partly to put some pressure on that to see, and partly just because it would be more interesting. So let's go ahead. I don't really know what I want to do today, so that's something I can do. I'll go ahead and thing I was saying. So yeah, oops. Let's get this in the right spot. And so yeah, the other doc, what does that one do? So I could try doing some of these other specific tasks that I have set up. But sure, let's at least just do a little bit of work on this. So I gotta tell you up front, I'm terrible at aesthetics. So I'm not the guy to be making the procedural generated terrain here. This is not something I'm good at. If anyone out there wants to contribute, that's something useful you can do. It's a little early to be doing anything like that, but you could potentially do it. Where's the gen? Corner weights, here we go. All right, so yeah, this is my terrible biome stuff that doesn't work. And so let's do this. Let's compute this weight outside of compute height field, because this is another biome-ish thing. Height lerp. Now let's compute it here. And store it. Height lerp. And pass it in. And now we can access that variable in down here. And so I'm going to change this. So int bt equals block type of j of I, which we computed above. And we're going to cheat and say if height lerp j of I equals 0.5, bt equals 2, else bt equals 1. Let's see if that lets us actually see how the terrain generation varies. Now it's discontinuous because I broke something with that height weight stuff. So let's fix that before trying to judge this. Weight is here. Pass it in here. Weight. That seems the same to me. Let me undo all the way back and see if there was something in the weight computation that I lost. Oh, X and Y. So yeah, this X has to be X plus I, and Y plus J. I could maybe call it obbgnauts just to express my intense loathing. So do these look like different kinds of things? It's hard to say. Like the weird gigantic spike we've been seeing all along. Okay, so it looks like the green stuff has spikes of sort of different frequencies. Whereas the sand is more homogeneous Perlin noise. So that would mean the green stuff is probably where I'm scaling the heights. And or squaring them, and the square means that large values stay large but small values shrink more, which means the data becomes more spiky, and this spike is in the lowest frequency or something. So let's actually show the where that changes by saying equals stb lerp height lerp j of I 1,7 int LZ4 is not Charles Bloom's. The stuff that Charles Bloom writes about on his blog is usually his own, is rad stuff that he doesn't release publicly. LZ4 is, I think it's Jan Collet. Okay, so here you can see isocontours of that weight function. Here's the giant spike. It's unfortunate that the choice of colors is not great because they're all kind of the same, but for this middle region, but whatever. Yeah, I guess that's reasonable. And so that we can change the scale at which we switch between those. So Perlin noise, oh right, so 256. So if we do it every 64, it should be more fine-grained switching between them, which is a terrible idea for biomes, but just want to kind of see what's going on here. Yeah, and now the sand patches are smaller, and we still get a spike over there. So yeah. All right. And then I want to fix the bug, which is that I never multiplied by the sine function. So we compute the sine. Oh, right. I don't square it. I now actually multiply it by like quintic, quartic, cubic, quartic. Yeah. I raise it to the fourth, and that makes things really spiky. So, so now I'm doing the sine correctly, which shouldn't change the sand at all, but changes the other things. I think, if I did this right. Yeah, because it used to be flatter. Well, it's hard to say. Whatever. All right, so what does this terrain look like up close? Oops, overshot. It looks like that. All right. So that old biome code is just so terrible and broken, I'm just going to delete it. This current code is dumb too, but the biome code just didn't really help, so. And it wasn't going to handle some stuff very well. I guess because I was using fast noise, which isn't very good. Anyway. All right. Thank you guys in the chat for answering the questions of the other guys in the chat, or excuse me, people in the chat, for both of those noun phrases. So let's go ahead and do the thing people kind of suggested or clamored for or whatever. Okay, well, first of all, see, I'm sorry, I always push so many things on the stack in my head here. So we load all these textures, and there's an implicit mapping between the blocks types and the textures, that they're just in order. So let's go ahead and start making some block types. Although, maybe I should fix this other issue first. So in Minecraft, the block types basically describe both the textures and the shape. And so you have these weird things where it's like, well, this thing has stairs, but this other type doesn't have stairs yet, but then the next release adds the stairs. And what you might like is for them to just be orthogonal. You want the geometry shape to be 1 byte in the 3D array and the texturing to be a different byte. And there's facilities to do that in STB voxel render. But those facilities don't quite provide the functionality the way I'd like to use it here. So the thing to do for that is to fix STB voxel render, to add a new mode to support that. But that's some mighty fine yak shaving. So I think what I'll do is I'll just do the Minecraft style way of doing it for now, knowing this is not long term. So somewhere I have a BT thing. And OBG data, yeah, okay. So what are our types here? So sand, grass, dirt, pebbles, asphalt, wood. Sure, let me make this list here. Sand, grass, gravel, asphalt, wood, marble. Let's have those as our 6 types. Bike shedding is different from yak shaving. Bike shedding is about the fact that anyone has an opinion about what color a bike shed should be, so everyone contributes their opinion about what color the bike shed should be. And whereas if it's a complicated problem that people don't know very much enough, they don't have anything to say. And so you wind up with it being much harder to build a bike shed when you have a committee. Something like that. So yak shaving is about fixing a problem to fix a problem to fix a problem to fix a problem so that you can do what you originally wanted to do. And now we need to map from those to the other things. So I can't see over my microphone. Is the bottom of this on screen? Yeah, it is. Oh, I can lower my microphone. How clever. So somewhere there's a table that maps between these things, and I think it's in Mesh Builder. Text1. Text1 for block type. That is exactly what I'm looking for. Text1 for block type. There it is. Let's move this into main. That's where we have this list. And set block type texture bt sand 0. Set block type texture bt grass. This one. I need some better way to do this mapping. 3, 5. 0, 1, 2, 3, 4, 5. Yep, 5. Type texture bt gravel. I'm not sure which of those gravels is the best gravel. Block type texture bt asphalt. Asphalt is 9. BT would try using vertical redwood, which is probably not vertical in the orientation I'd set these textures up. And I don't remember which marble was the best marble, so we'll just do 16 to start with. So that's this table, and I need to write to it from a different file. So we do that for now. Those shouldn't be unsigned char, those should be uint8. I've just gotten in the habit when writing stblibs of just writing these things out the long way so I don't have to make types to deal with it. It doesn't matter. Like, hey, I only glance at the chat, so I don't actually pay attention to whether you guys actually know what you're talking about or not. I just see the topic and launch into the explanation because I'm a know-it-all who wants to explain everything. So now we are building this thing here, and I need to actually define this function. Void set block type texture int block type int texture. Six. I guess I'll just hardcode that because how many sides does a cube have? Is that ever going to change? Should I have a macro num cube sides, which is defined to be 6? Maybe. And then if you have hypercubes, and then we just don't need this code for now. Well, maybe I'll want to turn it on later. If I do turn it on later, I want to make sure this code runs first and that code runs second. Did I leave anything out? Yes, it shouldn't build. I no longer have BT solid, so anything that said BT solid should no longer work. I guess I got rid of all my BT solids. So now, mesh obbg.data. OBG funcs? What am I looking for? Oh, I'm looking for this. Marble to sand. So we want to go from sand to marble for now. Fix this in a minute. So where do we compute this? So we want to go from BT sand to BT marble, except this doesn't actually do the right thing because this goes 0 to 1. And so this almost never gets hit. So we want to say 0.9. All right. A little sluggish at the beginning there. I think I need maybe using too many threads. All right, so now we go to the marble. In this case, it's a dark texture. It's maybe too dark. The vertical redwoods are in fact vertical. So there you go. I can make trees out of those now. I don't have any leaf textures. There's the grass. That's a tolerable grass. Nothing like Minecraft grass, but whatever. And giant spike. All right. Only giant spike around. And this terrain looks pretty terrible, but That's only at the scale. All right, so now let's try to do the thing, which is people are proposing to have the terrain type depend on the height, and we can do that. Let's do a simpler thing first. Oh, I don't have a rock texture, do I? Have a rock texture? No, I don't. Rocks. Are any of these things rocks? Pebbles and mortar, not really. Let's go start run Pixar. No, it's not run, it's called data. Rocks, stone. I looked through this. I don't know that this has rocks. I think there was a terrible rock texture and I thought it was too terrible. I guess that's kind of rocky. I mean, I could use marble as my rock, but I'm just thinking of like something that serves the same purpose as the Minecraft stuff. Oh, while I'm here, I should check if there are leaves. I don't think there are. Might just be nice to make a little tree. You need something like leaves for it. Well, they have a lot of wood texture. No, it doesn't look like it. So, unless there a floor, stone, well, that's where we had one of the marbles. Ground. But ground. All right, dirt and gravel. Is that gravel? Like, oh yeah, that. Use blue gravel. That doesn't really plausible as rock. Rock should be. Rock needs to actually be solid, not rock, not like a stone wall. What's solid stone? I mean, that technically is gray granite. Yeah, I mean, it's kind of. All right, well, let's just use gray granite as a to start with. Stone. Gray granite. Okay. Set block type texture BT stone 20 and BT stone. So now let's change the mesh builder. So what we do is we set everything to stone, and then just the topmost block gets the BT. See what that does. So it's nothing's varying by height per se. It's more of a slope thing where there's a steep slope the stone will show through. Lowercase. Yeah. Oh, I hit a crash. Is GC null? Yeah, because the assert doesn't fire. So yeah, I think that's GC null. So I ran out of memory already? That seems crazy. Oh, that's not good. I don't know why there's multiples of these. I don't know how to make sure it's in the right one. Know what that means. That's writing EAX 0. ECX. So ECX is not null. Don't know what this would be. But let's run in debug instead of release, and then life will be better. And I want to cut down the number of threads because that was causing a little bit of a slow down. What are we doing? Let's see if that's better. Oh, hey, look, I have crazy bugs that are causing things to crash because I'm generating too much data, it doesn't fit in the mesh, or it's overflowing the meshes or something. Okay. So A, it's bad that that crashes. Like, I need to make it so that when I have bugs in my procedural gen, it doesn't crash. But does just mean I have a bug in my procedural gen. Oh, because I forgot this is divided up. It's doing slices. It's iterating over the region slices here. So where's that code? Is that above or below this point? Above. Yeah. So we're doing the segments. Here, okay, we're doing the Z segments. Wait, how did this code ever work? Oh, because it does the STB clamp. Okay, so Z stone equals STB clamp height minus say 2 minus Z0 minus Z segment size. And then we say memset 0 BT stone up to Z stone. Then we memset PCB block Z stone comma BT comma Z limit minus Z stone. And some of these may be 0. So if Z limit is 0, I think that's right. So I need to fix the way that that was crashing, but all right, so now we get stone poking through. Looks totally terrible. We get stone poking through where there are steep slopes. And so now let's put this back to the way that we used to work. If height lerp of j of I is 0.5, bt equals bt grass, else bt equals bt sand. I think I got those backwards. No, I think that's right. No, right, that's backwards. I mean, it's totally arbitrary, but I think it might be more tolerable backwards. But so the hills have grass, and then the weird lumpy stuff is sand. Of course, they stack on top of each other because it's not biome based. And then we can just cut off the grass if it's too tall. If height is greater than, do I use average ground anywhere when I compute the height field? Yeah, I do. If height is greater than average ground plus 16, BT equals BT stone. Or I don't know, what should be at the top of taller things? And the 16 was totally arbitrary. Yeah, so now we only get grass in some places, and then we get these ugly tall things. So let's flatten out our terrain because it's all way too spiky. And yeah, still weird because of the way they end up with this grass on top of these things, but whatever. So there you go. Now there's some marble on top of the mountain. Well, I know that's a terrible way of having the terrain vary with the height. It's just something to have something in there. I'll push the threshold down lower because it's too high now that the things aren't spiky. And then let's see about putting trees on here. Okay, so for tree, we need some leaves to go with our wood. So then in main, set block type, texture, bt, leaves, let's use this gross bowling grass. Or we could use the ivy. Probably be kind of weird. All right, and then in mesh builder, we want to generate a tree. So, how should you do this? And you actually need to know about trees from adjacent chunks because their leaves could extend in. I don't know by how much, so let's just add a bunch of padding here. Now we actually need to, we also need to know the heights. I need a way to systematize this smarter. We need to know the heights to know where the tree starts. These all need to be offset by 4. Should be a pan-define or something. Then down here where we access it, and wherever else we access it. Oh, that was it. Wasn't there these? Ah, here it is. All right, so since I don't have a pan-define for that, let's make sure I didn't miss one. I need to actually expand these 8 and 8, 8 and 8. Why do I have both height and? I just do. Okay. I ever access both of them? I don't think I ever accessed the continuous one. I might have because I want to be able to compute the slope. Maybe that's why I have it. Or oh, for eventual block types. Height field got pushed up to 8. Height lerp. Oh, height lerp doesn't have the offsetting. So that was already broken in the old code. Although it never shut up, so this should be 4. Height lerp, and then I access height lerp somewhere. And maybe that's it. All right, looks okay. Nothing seems to be broken. All right, so now we want to compute whether you have a tree. So the way we do that is height lerp of j plus, well, it's just weight. If weight is less than 0. Less than or greater than? Yeah, it's less than 0.2. So you're well into the grass region, then you might have a tree. So then you need some way of, let's do this. So we need some way of assigning trees so they don't overlap each other. You can't just independently compute at each column whether you have a tree there. And so there are a bunch of things you can do for that, like wing tiles. And one thing we could do is just like compute all the trees in this chunk and make sure none of them are too close to each other, you know, with some pseudo random thing. But doing that, making sure they're not too close to each other, we also needed to know about the chunks, the trees along the edges of the chunks, which means we need to avoid trees from adjacent chunks, and we don't even know where the trees in adjacent chunks should go at all. So we want something more systematic like wing tiles that we can just compute. So what we'll do is we'll say, I don't know how dense trees should be. Maybe every 8 by 8 can only have one tree. Every 6 by 6, I don't really want to do mod 6s. 4 is too small. So we'll say every 8 by 8 can have a tree. So I'll just copy this data. So we'll step 8 at a time. And we're starting from this weird offset because that's fine. So then we want to say, for the 8 by 8 region centered around this I, j, where would the tree fall for that one? So let's say we use a pseudo random thing. Is unoise.h. We just need flat noise. We don't need a continuous noise. So let's try flat noise strong. Since we're computing this pretty sparsely, that should be fast enough. Flat noise is strong of x plus I, y plus j, and seed some random number. Let's say return a, let's find it. 32 random. So then we say int x offset equals we can't push it too far outside of the center or it might get too close to an adjacent one, so we'll say 2 bits of it. So we'll say r mod 3 minus 1 and y off equals r and r shift right 8 and 3 minus 2. Sorry, that should be minus 2. Now we can then say if initialize this to 0, then we say if j plus x off, no, I plus x off greater than or equal to -4 and I plus x off is less than gen chunk size plus 4 and j y off j y off and chunk size y and x. And so if all those things are true, then that tree, then this is just to make sure this array access is not out of bounds, basically. And then we can say tree of and let's, yeah, okay, that's fine. Tree of j plus 4, I plus 4 is whatever the unused, some of the unused random bits. We'll use that to generate a random tree shape so it's consistent everywhere. And then the others were 0. And this could come out to be 0 and then we won't actually have a tree. All right, so that's where a candidate places where trees might be. And then here we'll say, okay, we definitely have a tree here. So if this case happens, else we reset the tree to 0. now we want to have like trees maybe be present or maybe not be present and stuff like that, but we won't do that yet. We're just going to do something here. So then we say int z. Well, let's just do this like this. Int cur height. Oh, this is all just a mess. We're going to be recomputing this every segment, which is kind of dumb. Maybe I should process the trees outside of these loops, because I can. There's no requirement that I actually do them all at once. So if I do it that way, then I can just do it while I'm computing the trees. And I don't have to store the stuff this way. Oh, not this. I can't move this down. I have to just move the tree stuff down. Which is just this stuff. Oh, I never used has tree. So I can move this stuff down. And just computes. So then we say here, if we reach here, then we could have a tree. And now we have to check if height lerp of j plus 4, I plus 4. Oh, with x off, actually. So j plus y off plus 4, I plus x off plus 4. Then we have a tree. And let's just do this. We'll say, we just want to draw the trunk just to see what this code is doing. So int height equals height field int of j plus, I should just store these into some variables. X, tree x equals x off plus, or I plus x off. Ty equals j plus y off. Tx ty. Ty plus 4, tx plus 4. And then tree height equals r and 3 plus 4 memset. No, we can't memset. Into z. For z equals height. Z less than height plus tree height. Yeah, and we don't need the center to actually be within the region. We need to know whether the leaves fall within the visible things. That's kind of the right test if the leaves are about 4 wide. But basically what we'll have to do eventually here is do a range test. Oh, we do have to do it. If I plus x off greater equals 0 and, oh no, it's tx and ty. No. Tx greater than equals 0 and tx less than gen chunk size x. And ty is greater than equals 0, and ty is less than gen chunk size y, then it is safe to actually draw the tree into this trunk, the tree trunk into this chunk. Semicolon plus z. We already have a z. Yeah, we do. I don't like to have nested variables that are the same, so I'll just reuse the z definition. And now this uses that old code that I used to do this that's inefficient, but I don't care because I'm only doing this for a few of them. So that's shift right the segment size log 2 dot block GCP arrow block. I don't think these are these right? Do we? Oh, it's GCP, right? That's this thing. Yeah. Okay, right. So the way this is GC arrow partial of the segment size log 2 dot block j of I z, and I don't even know what that's supposed to be masked by. And I don't know if that log 2 exists. H should be j. All right. Okay, so nothing is drawing because I screwed something up there, I think. Do we ever get inside this code? Okay, the Heitler test is wrong anyway. Do we ever get into this code? No, this code. It's not letting. Oh, I never assigned it. Huh. A equals BT would. Yeah, that would help. Okay, there you go. So now we're putting some trees down and we have a crash. Z is -1. Why is Z -1? Why is height -1? Height field of int reaches to -1? Really? Yeah, height was -1. How did that happen? Oh, I shouldn't have stopped debugging. That was dumb. Assert height greater than equal to 8. How does that happen? Oh, because we're dividing height by 2, which is not what I wanted actually to do. I wanted to scale all of these by 2. There we go. All right. So the tree is floating, so I messed up something there. They're not offset at all. They're all at their center point, so I screwed that up. I don't know why they disappear over some of these mountains. Because I thought I'm not doing that testing. Oh, wait, I am, right? I accidentally left that broken test here. Less than 0.2. So now it should only be out of the green things. Yeah, it's only out of the green things and the marble. I don't know why that one was floating. Yeah, there's a floating one. So it's looking at the wrong height. It's computing the height wrong or something. So maybe that's not offset correctly. Height field int ty plus 4, tx plus 4, ty. This is using j and I. Oops, wrong one. Okay, that should fix that floating problem. And then why are they never randomly offset? Rn3 minus 2, 8, 3 minus 2, tx. Is R always 0? R. X off, Y off. Those are none. Those are varying. There's still some. Oh, they are varying. Why did they look like they were all perfectly aligned? Oh, because they're only offset by a little bit. Yeah, I don't know how to do that right. Maybe I do need little wing tiles or something. Not sure what a good way to make the trees distributed well is. If for some reason somebody watching this has a good idea for how to do that, let me know. And let's make the heights more varying just to see that. So let's do our mod 6 minus 3. I should put 8 mod 6 minus 3. Now they should be more widely distributed and sometimes be right next to each other, which is what I kind of wanted to avoid. But yeah, they are more spread out. The lighting on them should be wrong because currently the lighting is computed entirely from the height field instead of from the objects. But looking, I don't know if that comes through on the stream, but you can see in the distance now, you can see these spikes on the distant stuff. Let me push the fog so it matches the view distance. View distance. I should hook that up maybe. View distance goes here. And then the fog was tuned to be 1920 or so. And here is where it's set for 1920. So view distance, I don't know what the right way to offset that is. So we'll try it as a fraction. Calc 1860 over 1920. 0.97 about. Yeah, now the build is like, oh, because I'm in debug build. Now when I do this, nothing should pop in. This fog should now be set to avoid the pop in until I start running faster than it can generate them. Yeah, that looks reasonable. I don't think the maps doesn't look reasonable. The map looks terrible, but you know, some weird alien world. It's fine. What programming languages do I know? Well, C and C++. I just use C for everything. I've never really learned Perl, Python, Ruby, any of those modern things, because I can use C well enough that I don't really need to switch to a different language. Like if I just want to write a quick dirty tool, I can do that actually in C. The C libraries are not very good for doing that stuff, but I have my own set of libraries that do a reasonable job. Expression GC, so that's out of memory. I went too far. So let's go ahead and add leaves to these trees. Maybe make them a little bit less offset and make this height mod like that. So then we want to say draw column GC txty height plus tree height bt wood, and then void draw column int, so it takes GC, which is what, in chunk, int x, int y, int z0, int z1, int block type. And what does it do? It says int z, says if then for z equal z0, z less than z1 plus with z, this tx becomes y and x. Let's call it build instead of draw. It's weird to call it draw. So let's make sure we didn't break anything by not making that change. Oh yeah, so I was talking about languages. And then, you know, so then I know a bunch of old languages, but that you probably don't care about, and I don't really know them. Like I, you know, once knew Fortran not very well. 6502 assembly language. I do know x86 assembly language because you can even see that when I occasionally look into disassembly to figure out my bugs. When I get a crash or something. I'm not sure why this mountain doesn't get trees on it. I guess it must be actually the desert type. Yeah, right. It's the desert type and it gets the mountain texture because of the height, not because of the thing. Right, so let's put back the spacing of the grass versus sand to how it was, so they are much rarer transition. And now we are in a position that we can do the tree. So let's just fake it for now for a second. Let's just so we start, the leaves start 2 above the ground and they go up to tree height -2, no, just to tree height. I guess I go a little above BT leaves. Let's just hard code a little bit around it, and we'll figure out the actual way to do this later. Let's see what that does. I said BT, so I'm using the wrong BT that I passed into build column. Yep, BT. Yeah, I used to use Pascal back in the day, Turbo Pascal day. So here's my terrible trees. Let's make it extend all the way out on the grass. So, where's that function again? So we want to use the threshold for deciding it. I went right by it. So the threshold for deciding whether to do it is 0.5, which is the current test for the grass. And there's other ways I could do this. I can store what the block types are. And so now those trees should extend right up to the edge of the grass, and they do. And let's change the bottom of the leaves to start leaf height equals height plus tree height over 2. So the taller the tree is, the higher up percentage, or not percentage wise, but basically it should start a certain distance from the top, but I'm doing it a little different than that. So leaf height, leaf height, leaf height, leaf height. All right. Even anywhere near being CPU bound. The terrain generation is CPU bound because you can watch the terrain draw in. So the rendering, once it's stable, once that stuff is stable, no. I mean, I'm in a debug build and the CPU frame render time is 2 milliseconds, and that's pretty much all of it. So again, you can see just into the fog, you can still see the trees there. And although here, if I were walking over this terrain, I wouldn't actually be able to see that far into it. There are places where you could walk and climb up a hill, especially that big giant spiky hill in the distance, that you would be able to see that horizon and see that stuff. So it's kind of silly that you're drawing it all the time, but yeah, so from here you can see some fogged out trees, and those are at the view limit, which is 1500. So those are like at 1400 blocks or so away. So there you go. I've got a crappy Minecraft thing. Why are these? I've screwed up the lighting calculations because these have a weird darkening away from the edges. I don't know what that is. And the lighting is using the height field entirely, which is wrong now that I have the trees. The lighting doesn't know about the trees and isn't lighting the trees properly. So I need to rewrite the lighting code now to actually look at the voxels instead of looking at the height field so that that stuff will work. There's a nice pit next to the spike. That's because I finally added that sign into it. But, you know, hey, there's the beginnings of something. It's too Minecrafty to do the tree thing, but it's also kind of real world to do it. And the spacing is still, they're too spread out. They look too much like a grid. And I don't know, like I said, I don't have a good solution for that. You know, it's not that noticeable, not that objectionable, but it basically just means like there are places you can pick that if you go down, it will just always be a gap. There will never be a tree here. This is a terrible example because let's go this direction. There should be in between, yeah. So if I go along this stretch, I'll never hit a tree because the trees are on this grid. Well, never hit a tree trunk. And I've unfortunately lost track of where it was. Yeah. So there'll never be a tree trunk in front of me because of the way they're spaced. So I need to fix that. I need to figure out a better way to do that. But it's decent beginnings here. And when did I start streaming? Anybody know? Is that more than an hour ago at this point? I think it is. So maybe that would be a good place to stop. And this is going to run out of memory soon anyway. Maybe the next thing to do will be to fix the lighting. Yep, now it ran out of memory. So one of the things, people think I'm joking about it, but one of the things I kind of want to do is make some kind of gun shooting game. There was Ace of Spades was a voxel shooting game, but Ace of Spades had a 512 by 512 map, I think. And, you know, here I can see 1,500 blocks in one direction. So I'm seeing stuff that's 3 Ace of Spades maps away. So you could make a very large map compared to Ace of Spades, obviously an infinite map. I don't know what kind of shooting game you could do with that. I know shooting games are really boring and dumb, but my area of expertise as a game developer is not doing amazing cutting edge game designs. My skills as a designer are in making puzzle games and in cloning things. So I don't want to clone Minecraft, but you could easily make a shooting game. And rather than a cover-based shooting game, maybe something like Arma, where you have these long-distance engagements. I mean, another possibility, of course, is you can make a helicopter, you know, some kind of flying game where you do fly at the speed I'm doing in this demo, where you're like, hey, look, you can whip around pretty fast over the train rather than being down in the train and walking at human walking speeds, which, you know, is this. Also, we can have the voxel scale be very different. Maybe make this is how high you are above the terrain, which would mean like these trees need to be much bigger. That, you know, maybe the 2 or 3 times the Minecraft scale, like the, you know, Minecraft block is a meter, so you might have 2 or 3 blocks per meter. That might be worth doing just to differentiate a little bit. It means the view distance of 1,500 blocks is half or a third of the meters, so it would only be a 750 or 500 meter view distance. But that would be a different feel. Yeah, I really gotta fix the lighting. That looks so terrible. It looks like bad screen space ambient occlusion. But there you go. Will there be an STB voxel collision lib? I don't think it's a complicated enough problem to be worth libraryizing. I actually was working at one point a long time ago on a lib that found what parts of voxel libraries were, of voxel worlds were connected, so that you could use that, you know, like Ace of Spades and Dwarf Fortress. If an area of the map ends up totally disconnected, those collapse. And it's also useful for pathfinding. It was gross and a mess, and I never finished it. And I could dig that back up if that was something that I thought would be useful for this game. And leave it as a library that's standalone from OBBG as well, instead of baking it into OBBG. That would be possible. Somebody wanted rivers, I remember the other day. I'm not sure what a good way to do rivers procedurally would be. Yeah, and I gotta figure out a way to do biomes, because this thing only supports 2 biomes the way I'm doing it, which is just kind of dumb. But hey. Yeah, so I think that's it. I think I'll wrap here. And again, I'll talk in chat for a little bit, answer questions that I haven't answered yet. Hopefully I've done enough flying around here that you guys got the full idea of what we see when we fly around in this. I can stop doing that. I could do a release run, but I don't think it really matters. I will push this up right now. Somebody else has a pull request into me for a VS 2012 project file. And so if I ever get around to merging that and you guys are running on a modern Visual Studio, you can actually build it yourself. You still need to do the STL and stuff. Okay, and here you can see that mountain in the distance. So you can watch how it fades out with the fog that I'm doing, which is not realistic fog. Realistic fog fades out in a very much more gradual way. This is designed to maximize your view radius, so you get to see stuff way far away and still see it clear, not clearly, but less unclearly than real fog would do. So, you know, it's a hack, and it's an aesthetic choice whether you want it to make it more realistic or not. And that's part of the STB voxel render library, and we'll make OBPG in the long run will be more flexible about how you can do it and let you pick exactly how you want your fog to be. But for now, I'm just using the stuff that's supplied in voxel render as a default. All right, so that's it, and see you on the stream. Bye.